Hello, Algebra students. Today we're going to be covering the Unit 4 activity. That's the Algebra 1 Unit 4 activity. It's called Special Linear Relationships. And it's about, the theme is on rock climbing. So if you watch the video and you still need help, feel free to email me to get additional help anytime. My email is ttrigg@ofy.org. Okay, so with that, let's share my screen with you guys. Okay, so on page 3, you can see the introduction here. Feel free to follow along as I read aloud. Linear regression models are a helpful tool for working with bivariate data. That means data that has two variables. We use these models to analyze, interpret, and predict outcomes from data. We can display data in various ways, including scatter plots. You've probably seen scatter plots before. It just has like a bunch of dots all over the place. In this activity, you'll apply linear regression models to solve a rock climbing club's problems. The leaders of the club are looking for ways to analyze data about club members that will help them make decisions. Okay, so Jeremy is on the planning committee for the rock climbing club. He is putting together a trip where members can go outdoor rock climbing. He is trying to determine how high the group should climb and how long the trip should last. He calls multiple parks in the area that offer rock climbing and collects data on the height of the rock formations and the average time it takes people to reach the top and come back down. The data he found is shown. Okay, so you can see the data here. So for one of the climbers, you could see it took one person 30 minutes to climb a height of 85 feet. It took another person 45 minutes to climb a height of 120 feet, and so on and so forth. So you could see as you go down the data, some climbers are much faster than others. I think this first climber is quite on the slow range. And then you have climbers that are much, much faster. For example, this person in 55 minutes climbed 180 feet. That's much faster. Okay, so use the graphing tool to determine the line of best fit for the scatter plot. So what we're going to do, first you're going to go ahead and click on the data button here. And then from here, what you're going to do is you're going to put in the data that is found right here. So the first piece of data is 30 minutes, 85 feet. So we're going to go in for the X, you'll put 30. For the Y, you'll put 85. And when you press plot, you can see it plots here onto the graph. So far we only have 1 point, but you can see it's 30, 85 right there. 30 on the X, 85 on the Y. Now we're going to go ahead and plot all these points. So 45, 120. $115, $298. Back 298. 87, 194. So I'm going to stop there, but I want you to go ahead and put all of the points on here. So all of these data points, I need you to put them on here. Okay, I'm only going to do 4, but you are going to put all of them. Okay, so your answers are going to be slightly different than mine, and that's fine. That's expected because you're going to put in all the data. I'm just going to use these 4 pieces of data, but you get the point. And then when you get plot, that plots it right here. Okay. Now, what I want you to do after you've plotted all of the points, all of these points onto here, so you should have a plot with much more points than I do. Then I want you to go to relationship and go to linear. Okay, we're going to have to change some things here. So first of all, the M is the slope. well, you can just click best fit. Oh, there you go, best fit. So you can click best fit and it'll give you the line of best fit. Now in my case, my slope is 2.39. You know, yours will be different. Yours will be different because you're using all of the points, but mine says 2.39 and my B, my y-intercept is 8.93. Okay. Again, yours will be different. All right, so now I've got my M and I have my B. So now I could write my equation here. So replace M and B with the values of the slope and y-intercept, round each number to the nearest tenth. So for mine, my slope was 2.39. It says round to the nearest tenth. So the tenth is the first decimal place. So I'll put 2.4. Yours might be the same. Yours might be a little bit different. It should be at least similar to that. My B is 8 point, and also I'll say 8.9 because that 3 won't round up that 9. Mosquito in here. Okay, so that's what mine is, but yours will be potentially different. Again, because you're using all of the data points. I'm just using 4 of the data points. Okay, complete each statement explaining what the slope and y-intercept tell Jeremy about the trip he's planning. Select the correct answer for each drop-down menu. So the slope of the line tells Jeremy, not the time, the rate. So the slope is generally, it's a rate. And the slope in this case is the rate at which people climb the rock formation. So it's a function of the time and the height. So that gives you a rate. The y-intercept is the starting position. So what that is the initial height where each team starts climbing. Yes. Okay. And there you go. This one doesn't make complete sense, but I think that's the answer they're looking for. Okay. Which 3 statements are true about the correlation shown in the scatter plot? Let's see, the line of best fit cannot be used to make accurate predictions. No, the line of best fit does make accurate predictions. The correlation coefficient is approximately 0.96. That's true. I'll explain what this means. So a correlation coefficient of 0.96 means that your line of best fit is very close to the points. So you can see my points are not far off from that line. So that means that it's going to have a very strong correlation coefficient. The closer the correlation coefficient is to 1, the better the relationship, or the more you can use to predict. So a correlation coefficient of 0.96, which our line has, is a very strong correlation, very strong correlation. The strongest it can be is 1, or -1 if it's going the other way. But a correlation coefficient of 1 is kind of unheard of. A correlation coefficient of 0.96 is a very strong correlation. So in this case, we have a 0.96, which is a very strong positive correlation because the points are very close to that line, you see. Okay, the correlation coefficient indicates a weak positive correlation. No, that's not true. It's a strong, so strong positive correlation. Line of best fit can be used to make accurate predictions. Yes. Okay. So those are the ones I would say are the correct. Okay. Now, again, your equation will be slightly different, but in our case, so you'll get slightly different numbers than I do, but let me see here. So at a height of 120, so what that represents is that's the height is the y-axis, right? And the x is the time. So height and time. So since height is the y, what we're going to do is, when it says a height of 120 feet, that's going to replace the y in our equation here. So let me go ahead and clear this. This is from last time. So our equation, well, my equation, and again, yours will be slightly different because you're using all the data points. But my equation is y equals 2.4x plus 8.9. Now your equation will be slightly different, but that's expected. Okay, now the first height we want to see is 120 feet. So we're going to replace y with 120, and we're going to solve for x. Okay, so I'm going to subtract 8.9 both sides. So on the right side, we have 2.4x. On the left, we have 120 minus 8.9. Got my calculator here. That's 111.1. Then to solve for x, we're going to divide by that 2.4. So we divide by the slope. Divide by 2.4. And so in my case, that's 46. Let's see, they round to the nearest tenth, I think. To the nearest hundredth. So that's 2 decimal places. So 0.29. And again, yours will be a little bit different, or possibly a lot different. 46.29. Or I would do the same thing, except instead of 120, I would replace the y with 215. So it would be the same situation, except instead of 120 for the y, it would be 215. Okay. And I'm using my equation. Don't use my equation, use your equation. But you'd still use the 215 and the 120. Okay, so subtract 8.9. So 2.4 x on the right side. This cancels. And 215 minus 8.9. 206.1. Then divide both sides by 2.4. Divide by 2.4. And in my case, that's 85.88. Your answer will be different. And then do the same thing for this one. You'll be replacing y with 400. Okay. Jeremy has heard a lot of people in the club talking about tackling a 950-foot rock formation. Jeremy has set a limit that they won't climb anything that takes longer than 7 hours. So they have enough time to travel to and from the place. Will it be possible to climb 950-foot rock formation within Jeremy's time constraint? Explain why or why not. So in this case, they're talking about the height is 950. So I'm going to go and use that same equation I had from before, this one. Except now I'm going to replace the x with 950. Okay, so y equals 2.4 x plus 8.9. And I'm going to replace the x with 950. And we're going to try to figure out how much time that'll take. Okay. Yeah, because the y is the height. Whoop, my bad. The y is the height. So I'm going to replace y with 950. And we want to see how much time that's going to take. So in our case, since we want to see how much time that's going to take, we're going to replace the y with the height. My bad for any confusion. And we're going to solve for x. So we want to see if they'll have enough time to climb this thing. Well, we want x to be less than 7 because, well, less than 7 hours. So we want to see how much time it's going to take. If it takes them less than 7 hours, then they'll be able to climb it. Because as Jeremy points out here, that they only have 7 hours to climb. So we want to see, does this going to take less than 7 hours? So first thing, same as before, subtract 8.9. Subtract 8.9. Okay, so I have 2.4 x equals, so 950 minus 8.9, 941.1, then divide by 2.4. So we have 392.13. Now this is in minutes. So we want to know how many hours that is. So if I want to figure out how many hours this is, well, I know that for hours, there's 60 minutes in each hour. So I'm going to go ahead and divide that by 60 to figure out how many hours that is. So that's about 6.54 hours. After I divide this by 60, look at this. So it looks like they will be able to complete this climb in less than 7 hours. So now I want you to explain that there. Again, yours might be different. Yours might take more than 7 hours. So just for me though, from my equation, it took less than 7 hours. So I would write that the climbing club will be able to finish the climb in about 6.5 hours. So they should be able to climb the formation within the time that they have. Because remember, they gave themselves a 7-hour window. So if it only takes them 6.5 hours, then that's good. Now I should show some of the work here. So what I'm going to do here, above this, I'm going to use the equation editor and show basically this work. Okay. Show some of this here. So first, y. Use the equation editor. And my equation was y equals 2.4x plus 8.9. And I replace the y with 950. And then I subtracted 8.9 both sides. So that gave me 941.1 equals 4x. Then after dividing by 2.4 each side, that gave me 392.13. And your numbers will be slightly different because you're using a different equation. And we would say that that's 6.54 hours. Okay. And there you go. Go and press OK on that, and it shows up nice and neat, just like that. So it's nice to have the equation editor. You can just kind of do it. It looks really nice. It looks all mathy and everything. So that's good. All right. And that's it. Okay. Now again, I want to emphasize that your numbers will be slightly different because you will be using all of the data points. I only used 4 of the data points, but you're going to be using all of the data points to create that line of best fit, which will give you a slightly different linear equation. So don't use my equation when plugging in all these values. Use the equation that you get after putting in all the data points. I think I emphasized that a lot. Okay, so just make sure you do that. I guess that's it. If this didn't make sense, you want to walk you through this whole activity, that's fine. Just feel free to email me, and the email is ttrigg@ofy.org. All right. Well, with that, I'll see you next time.